together. First thing you have to keep in mind is that for 10 and 11, I had to assign charges to those. So I assigned 10 cobalt at +2 and the nickel and 11 a +3. All right, so when you have a mixed set of problems, it's best to identify what kind of equation it is, and then we'll sort out what it is and how to do it. So here I have a single element and another single element. So I know this is synthesis. This is the only thing it could be. So I know that this Al and O are going to end up together on this side. And I can check the charges. And I know that aluminum is +3 and that oxygen is -2. And so if I crisscross those, I get this. And then all I have to do is balance. And so I haven't been doing atom counts. And it's kind of bad form of me not to when I am preaching to you guys all the time that you should probably do atom counts. So I'm going to do them on a few of these just so you can see me. Best practices, know that I need to do this. So I have 1 and 2, I have 2, I have 3. Okay. So I know that that even number is never going to be odd. And I know that I can make an odd number even by multiplying it times 2. So I'm just going to multiply them times each other. So basically what I'm saying is that I'm going to put a 3 out here and multiply that times 2 equals 6. And I'm going to put a 2 out here, multiply that 2 times 3, that gives me 6. So now I have 6 oxygens on both sides. And I now have 4 aluminums. 2 times 2 aluminums is 4. And I have 1 over here, so I need to put a 4 here. 4. I am now 4, 6, 4, 6 balanced, and that is how we do synthesis. Next one's a double replacement. I have 1, and then I know that SO4 is a polyatomic ion. If you don't know, you should count your elements. 1, 2, 3. Know that anything more than 2, you should start looking on the back. And immediately I'm going to look at anions because there aren't that many cations here. And it's in the anion position. So I'm going to start looking for SO4. And I'm going to find it right here. It's a sulfate. It's -2 charge, which is, I'm going to go ahead and write that up there. That way when I do the rest of the work here, I'll know. Okay. So step 1, by the way, step 1, when I talk about step 1, what I mean is that right there. Step 1, identify cation and anion. Step 2, change partners. Step 3, crisscross oxidation numbers to subscripts to create neutral charge. Step 4, balance chemical equation. Don't forget atom counts. Again, trying best practices. Don't forget diatomics when things are by themselves, like oxygen, nitrogen, fluorine, chlorine, bromine, iodine, and hydrogen. It's got to be H2 or O2 or F2. And subscripts do not cross the arrow unless protected by parentheses. So, get this crazy swimmy vision. Okay. All right, so back to work. Identify cations and anions. So first thing is always a cation. Second thing is always an anion. Cation, anion. Step 2, change partners. So Mr. Barium is going to end up with Mrs. Chlorine, who left Mr. Magnesium. And he's going to end up with Mrs. Sulfate. So that's step 2. Step 3, crisscross oxidation numbers. Barium +2. I'm going to stop doing this for stuff that I know because I know chlorine's -1. I know magnesium is +2. And I know sulfate is -2 because I wrote it down over here. The 2's cancel. +2 and -2 they cancel. So no crisscrossing. This 2 doesn't cancel this 1. So that 2 crisscrosses to this chlorine here. And then I just have to balance. So I have 1 barium, 1 barium. 1 SO4, 1 SO4, 1 magnesium, 1 magnesium, 2 chlorines, 2 chlorines. Hey, I'm done. I don't have to balance anything. All right. Zn and H2SO4. This is a single replacement. I'm going to just double replacement, synthesis, single replacement, decomp, 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 decomp. I'm not even going to do this section here. I'm going to leave it to you to do. I'll do one as an example because it's really easy. Decomposition. This goes to chromium. This goes to chlorine. Chlorine is one of my diatomics. Go to 7, make a 7. Chlorine is a diatomic, so it never exists as just Cl, so it exists as Cl2. And then all I have to do is I have to balance it. So I see a 3 and a 2 again, so I'm going to throw a 2 here, 2 here, 3 here. 3 times 2 is 6, 2 times 3 is 6, 2 chromiums, done. That's the rest of this decomposition. I'm going to let you do those on your own. I'm more concerned about single replacement, double replacement, and being a good example on how to do those. So, step 1, identify cations and anions. Zinc is a metal. It is definitely a cation. Hydrogen is a metal, kind of. Definitely a cation. And SO4 group is definitely an anion. So they change partners. So Mrs. Sulfate leaves Mr. Hydrogen for Mr. Zinc. So zinc is now with Mrs. Sulfate. And Mr. Hydrogen is living in his bachelor pad. Again, now, that 2 does not cross that arrow. Subscripts do not cross arrows unless they are protected by parentheses. But this hydrogen is by itself. And what do we know about diatomics? N2, O2, F2, Cl2, Br2, I2, and H2. H2. Okay. And then we've got some charges that we have to come up with. So zinc is +2. Sulfate. So 4 is -2. And crisscross. And so we're done there. And again, it looks like we're balanced. 1 zinc, 1 zinc. 2 hydrogens, 2 hydrogens. 1 SO4 group, 1 SO4 group. Okay. All right, so I have barium and sulfur, BAS. I know that barium is charged +2 again. And sulfur is charged -2. No crisscrossing, no muss, no fuss. I'm done. That's pretty easy. Next one, COO. This is -2, this is +2, therefore it's just COO. Nickel, this is a single replacement. This is synthesis. Single replacement because I have 1 element by itself, and then I have 2 over here, so, or 2, an anion and a cation, another cation. Identify cations and anions. Done. Switch partners. Nickel ends up with OH plus manganese. I told you on the board that nickel is charged +3 in this problem, right there. So +3, OH group is -1. Hydroxides give everybody fits because they think it's just 2 letters beside each other somehow, but OH group is one of the most used anions in all of chemistry, so remember OH hydroxides. They are -1, so we have 3 here, and then we have to balance nickel, 1, 2, and I have 3, 1, 1, and 3, sorry. 1, 1, and 3, I'm tired as well. Okay, so done. I think we're balanced there. All right, so we have KCl and MgNO3. So this is a double replacement because I have 1, 2 things here and 1, 2 things here. And Mr. Potassium is going to end up with this NO3 group, plus sign, and Mr. Magnesium is going to end up with Cl. And charges, so potassium +1. Nitrate -1. Magnesium +2. Chlorine -1, so the 2 goes down here. So I've got some balancing to do. I have 1 potassium, 1 chlorine, 2 chlorine. So let's fix that first. I'm going to throw a 2 out here. That means I now have 2 potassiums, so I'm going to throw a 2 out here. So now I have 2 potassiums and 2 nitrates. So let's just go across. I have 2 potassiums, 2 chlorines. 2 potassiums, 2 chlorines. 1 magnesium, 2 nitrates, 2 nitrates. So I'm done. It is a 2-1-2-1. Sorry if I crammed that in there, but okay. This is combustion, and I told you not to do it because it's CO2 and H2O. These are always the products. All you have to do is you have to balance after that. So, I mean, I think 4 and 2 and 4 and 2. At least they made it easy for me. No, they didn't. 2 and 3, 2 and 2 and 4. Nope. Oxygens should have done them last like I intended. So now I have 2 times 2 is 4, plus 2 is 6. 6 oxygens, 2 carbons, 4 hydrogens. Now I'm balanced. So it's a 1-6-2-2. You didn't have to do that one. I just wanted to show you that really the only tricky part is the balancing part. Okay, again, decomposition, do it on your own time. It's too easy. Actually, I could do this one because I want to show you something. You know how the 1s are always here? If I don't see anything, there's a 1 there. And this decomposes silver. And let's say that it was a... let's say that this was a transition metal. The only way for me to know that it's charged is either it has to be on this periodic table, I have to specify to you what it's charged, or this subscript came from up here. This subscript came from up here, so that silver is charged +1 if you needed it. Okay, keep on going. Another decomposition, Don't care about those. Those are going to be on you to do, too easy. Here we go, a synthesis. We have HBr. H is +1, Br is -1. Gotta throw a 2 out in front of here. Done. Sorry if I'm shortcutting that too much, but really, synthesis and decomposition I just don't care about because this and this is far more important than this. Okay, identify cations and anions. Switch partners. H plus PO4. We know that hydrogen doesn't exist by himself. He always is diatomic. Crisscross charges, +2. And what's a PO4? PO4 is -3. So we have a 3 down here and a 2 right here. And then we got to get busy balancing. So I have 3 bariums. I'm going to fix that really quick. That's fixed. I have 2 PO4s. I'm going to do that. That gives me 6 hydrogens, so I'm going to do this. So now I have 3 BAs. 6 hydrogens. 6 hydrogens. 2 PO4 groups. 2 PO4 groups. And we are done. Okay, number 19, double replacement, single replacement, one thing by itself, 1, 2, 1, 2, nobody by themselves, double replacement. All right, so identify cations and anions. Done, very easy in compounds. Switch partners, so Mr. 10 is now with Mrs. NO3 plus Mr. Aluminum is with Mrs. Hydroxide. Step 3, crisscross charges. Now, what is 10 charged? Well, Where do you think that 4 came from? E is charged plus 4. And what is an NO3 group charged? NO3 minus 1. And aluminum is plus 3. And this OH group is minus 1. So we crisscross, so that's NO3 gets a 4. OH gets a 3. And then we have to balance. So I have 4 hydroxides and 3 hydroxides. Woo! This is going to get busy, isn't it? Okay, let's do it. I'm going to multiply 4 times this, which is going to give me 12 of those. And I'm going to do 3 times this. And then I'm going to do 3 times 10 here, which is going to give me 12 NO3s. And I'm going to do 4 times this, which is going to give me 12 NO3s, and I'm done. I have. And I do this accounting in my head really quickly. You should be doing atom counts. Like, if you haven't been doing this for years and years, this is all going to get really confusing, and you're going to start slapping numbers in here, and it's going to become really messy really quick. But I have 3 10s, and 3 times 4, 12 hydroxides. So I have 3 10s, that 3 times 1 is 3 10s, and 4 times 3 is 12 hydroxides. Then I have 4 aluminums, and 4 times 3, which is 12 nitrates, 3 times 4, which is 12 nitrates. That's it. I'm done. I'm balanced. That is the sheet. Don't forget, PbSO4. The 1 is assumed to be there. What is this lead charge? It's charged plus 1, but it doesn't matter because it's just Pb plus SO4. See what I mean about decomposition? Ca plus OH, and then we have to balance it. 2 Fe plus O, and then we have to balance it. So 2 Fe's, 3 oxygens. Copper plus ClO3, and there's 2 of those. Iron plus CO3, there's 3 of those. That's it. Oh, I messed up. You see where I messed up? Did you catch it? You see these 3 oxygens? You lose. Oxygens, diatomic. That's going to change my whole deal. Again, 3 oxygens and 2 oxygens. I'm just going to multiply them times each other to get 6 oxygens, and now I have 4 irons, so that changes that. Okay. I hope you guys like the video. I hope a bunch of y'all watch it. I definitely hope you learn how to do this. We're going to continue practicing on this, and I will see you all tomorrow.